Okay, so hello everyone. Alright, so the next program in chapter 5 is fallingDistance. Okay, so when an object is falling because of gravity, the following formula can be used to determine the distance the object falls in a specific time period. So this is the formula. Distance is equal to half gravity times time squared. So the variables in the formula are as follows. D is the distance in meters, G is 9.8, and T is the amount of time in seconds that the object has fallen. Write a method named fallingDistance that accepts an object's falling time in seconds as an argument. The method should return the distance in meters that the object has fallen during the time interval. Now demonstrate the method by calling it in a loop that passes the values 1 through 10 as argument and displays the returned value. Okay, so with this question, we've been given a formula over here to calculate the distance. Okay, the distance the object falls in a specific time period. Okay, when an object is falling, because of gravity. All right, so they've told us what these variables are. So basically what these values, these letters represent. So we're supposed to use this formula to calculate the distance given the time. Okay, so we're going to create a function, we're going to create a method that's going to accept the time as the argument, and we are going to call that method in a loop in main. We're going to call that method in a loop, and it's going to loop through from 1 through 10, and 1 through 10 is the time. So we're going to pass 1 through 10 to the method as an argument. Okay, and then we're going to use it to display what's the distance at second 1. So this time is in seconds. So what's the distance at time 1? Well, meaning 1 second, second, third second, and so on. So let's create the program, and then it will make sense as we go on. So I'm going to go ahead and create the class. So public class fallingDistance. And I'll create the main method here. Okay, so let's see. Okay, so it says write a method named fallingDistance that accepts an object falling time in seconds as an argument. So let's write a method named fallingDistance that accepts an object falling time in seconds as an argument. So I'm going to go ahead and create that method, but I'm going to create it above the main method. See, others created below the main method. It still works. As long as you create the method, it's still available in this class. So I'm going to go ahead and create mine above the main method. Both cases work. So it's going to be a public static method. Public because the method is accessible to code outside this class, and static because the method belongs to this class. Okay, so when you read further, it says the method should return the distance in meters. Now the distance that is going to be returned can be a double value, can be, let's say, 25.2 meters, right? So because of that, I'm going to return or set the return type of this method to a double. So public static double, and I'm going to call the method fallingDistance because the program said we should write a method named fallingDistance. So I'm going to call the method fallingDistance. And when you read further over here, it says the method should return the distance in meters that the object has fallen during the time interval. So I know that I'm going to return the distance. I know I'm going to return the distance, but over here, I meant to read this. Write a method named fallingDistance that accepts an object falling time in seconds. So I know that it's going to accept an argument. Okay, it's going to whoever is calling this method has to provide an argument, and in that case, because it's going to accept that argument, I'm going to define a parameter which is the falling time in seconds. Okay, so that's what this method is going to accept as an argument. So because it's going to accept the falling time in seconds, I'm going to go ahead and define a parameter. In this case, I'm going to call that parameter falling time. Okay, so this method is going to accept the falling time in seconds, and since it's in seconds, I'm going to go ahead and set it to an integer. I'm defining the argument that's going to be passed to this method as an integer. So int falling time, and it's going to be in seconds. All right, so in this method, all we have to do is use a formula given to us to calculate the distance the object falls in a specific time period, and then return this distance, because over here it says the method should return the distance in meters that the object has fallen during that time interval. So I have the formula. I'm going to go ahead. We in the formula, we're going to calculate the distance. Okay, so I'm going to go ahead and create a variable called distance that's going to hold that distance, and I'm going to calculate the distance by using this formula. So okay, so the first thing I see is half. So half is 1 divided by 2, right? And I'm going to surround all of them, basically all of that with parentheses, just so that I follow the order of operations, right? Okay, so when you punch in, let me use the calculator for a second here. When you when you divide 1 by 2, when you punch in 1 divided by 2, you get 0.5. You would expect that you're going to get 0.5 here, but because Java, so anytime that Java sees this / and both of the operands are integers, it's going to consider this division as an integer division because both of these operands are integers, right? So instead of this calculation resulting in 0.5, it's going to result in 0. It's going to only give you the integer part of this result, 0.5. It's going to slash off anything after the decimal point because it's going to consider this as an integer division because these two operands are all integers. In order for this calculation to result in a double, in this case 0.5, at least one of these operands has to be a double. But here's the case where both of them are integers. Now you can go ahead and type in 0.5 here yourself, and that fixes it. But I want to stick with the formula. So the way we can make this work is at least one of these values has to be a double, right? So I'm going to convert one of them. You can convert either this or that. Okay, I'm just going to choose to convert the first one, and you can use typecasting to do that. So in order to convert that one to a double, I'm going to basically type in double in front of this number surrounded by parentheses. And now the double is what's surrounded by parentheses, not the number. It's not the number. So I'm putting double in front of. I'm typecasting this. Okay, I'm putting double in front of 1, which is going to change this 1 to 1.0. And because 1.0 is a double, because at least one of these numbers, in this case 1, is a double, this is not going to be seen as an integer division because at least one of them is a double, so it's going to return 0.5. Okay, so now that we have the 0.5, we have to multiply by g, and the program says over here that g is 9.8. So I'm going to multiply by 9.8. Okay, you can go ahead and even define a variable. Okay, I declare a variable called g, okay, which means gravity. Okay, you can do that. We can do that if you want. Let's do that. So now g is going to be equal to 9.8. We are defining it over here if you want, right? So I'm going to go ahead and replace this with now g. Okay. We'll see about this. All right. So I'm replacing it now with now g. Okay, and I'm multiplying by the falling time that the user passed. Okay, now I'm multiplying by the falling time that the user passed squared. So t squared. Actually, in the book it read as t squared, but I couldn't put a squared above this. I can, but I didn't do it. So t squared, we can use the math class to raise something to the other, or we can, in this case, since it's t squared, we can do the fallingTime times the fallingTime. We can do that, but let's go ahead and use the Math.pow, which is going to raise one number to the other. So we're multiplying g by the fallingTime squared, right? So I'm going to call the Math.pow, which takes in two arguments. It takes in the first number, which is going to be fallingTime, and the second number, which is still going to be fallingTime. We are raising, so it's going to be fallingTime raised to the power of fallingTime, which is going to be t squared. Basically, fallingTime raised to the power of fallingTime. So, yeah, t squared. And t is the argument that was provided by or sent by the user who called this method. So I'm going to terminate this, and let's see if everything is okay. Yeah, looks like it. Yep, it looks like it. Let's see. So this is taking care of that. This is okay. Yep, it should give us something. Yeah, it should be okay. Okay, so now that we've calculated. Now, if you want, you can also go ahead and put 9.8 here. I just did it because I thought it would be a good use of it. But I mean, g is always 9.8 regardless. I mean, it's 9.8. You know, in most cases. On the moon, it's different, and in other places, it's different. So, I think if I remember my physics well. All right. So now that we have the distance, I'm going to go ahead and return distance. So that because the question said the method should return the distance in meters that the object has fallen during the time interval. So I'm returning distance. Now in main, the program said that demonstrate the question said demonstrate the method by calling it in a loop that passes the values 1 through 10 as argument and displays the return value. Now let me see. Yeah, so demonstrate the method by calling it in a loop that passes the values 1 through 10 as arguments and displays the return value. So we're going to create a loop that's going to pass in 1 through 10, and 1 through 10 is going to be the fallingTime in seconds given to it, and it's going to tell us, you know, the distance. Okay, the distance that the object has, falls in the time specified. Okay, in the time specified. Okay, so I'm going to go ahead and create the loop, and it's going to be a for loop. And because we are starting from 1 to 10, we know that 1 to 10, okay, those numbers, you know, that number is the time. Okay, those numbers are the time. Okay, so I'm going to declare an integer variable called time and initialize it to 1. So we are starting from when time is 1 second, and as long as time is less than or equal to 10, meaning you're starting from 1 all the way to 10, do what's in the loop, and before you come back up and check to see if time is less than or equal to 10, add 1 to time. Okay, so basically time starts from 1 and does what's in the loop, comes back up to check if it's less than or equal to 10. If it's not less than or equal to 10, it will do it again and then check. So basically this loop is looping or iterating 10 times, starting from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each time, what we want to do is we want to call the method passing in the time, in this case with 1 second, and then it's going to return the distance that object falls in 1 second, and then it's going to add 1 to time. The second time around, time is going to be 2, and then 2 is going to be sent to the method when we call it as a fallingTime. And this method is going to return the distance that the object fell in 2 seconds. So that's how it's going to go. But it also wants us to display the results. We display the return value. So what I'm going to do is I'm going to, since I want to use the G option pane, actually, should I use the G option pane? No, let's go ahead and use this kind. No, not this kind. Let's just go ahead and display it using the system.out.println statement. Okay. So first of all, I want to create a header. First of all, I just want to simply create a header on top of it, just to display like the header, say time and then the fallingDistance. So what I want to do, we can go ahead, since we are working with methods, we can even go ahead and create a method just for that. So I'm going to create a method which is just going to display a header, like just text. So I'm going to call it it's going to be a public static method. It's not going to return anything. It's just so it's going to return void. It's going to return nothing. And I'm going to call it display header. And all this method is going to do is display the header. So I'm going to say system.out.println. And this method is going to display, let's see. So the first thing is the header is going to display is time. Okay, time, and I'm going to separate it with some tabs, a couple of tabs. And then fallingTime. And then I'm going to create a new line character. So the backslash n together is the new line character. It takes the cursor from where it's at to the next line. So anything that comes after the new line character is displayed on that line. It's displayed on that next line. So over here, I just want to underline the time with a couple of dashes, and then create some tabs and underline the fallingDistance. And now I've created my header. So now over here, before I call this, or before I use this loop, I'm going to go ahead and I'm going to call the display header method. So display header this way. We could have typed the system.out.println instead of this display header, but I wanted us to use methods since we're dealing with methods in this chapter. So it's going to display the header, and then it's going to go ahead and display the time and then the fallingDistance. So system.out.println it's going to display the time and then the fallingDistance. So first of all, it's going to display the time, and then I'm going to concatenate it with a couple of tabs. So a couple of tabs, and then I'm going to concatenate it with, I'm going to call the method this time a fallingDistance. The fallingDistance when the fallingTime is time. So time is going to keep track of what I can even change this to current time. This current time, I can change this to current time if you want. Current time over here. Now time is in second. So for int, current time is equal to 1, starting from the current time, which is 1. So this is going to display the fallingDistance of the current time. Okay, and then fallingDistance is going to be incremented, and it's going to display the fallingDistance of the second time, of the third seconds. So second 2, second 3, second 4, and all that, and all the way to 10. Now current time is in seconds. Okay, so this is going to display the time, the current time, which is, let's say 1, 2, 3, 4, all the way to 10. And this is going to display the fallingDistance in that current time. Okay. So let's see how this goes. Let's just compile this and see how this goes. I'm going to create a new folder. I'll call it fallingDistance. Then I'll save this here. We have a couple of errors. Okay, so current time. This is current time. I forgot to change this to current time as well. And I'll compile this and it works. So let's run it and see what happens. Let's do this here. Okay. So it kind of is working. So let's go ahead and close this tab a few times. Let's see. 2 tabs here, 2 tabs here, and then 2 tabs here. What happened? Okay, so I'm current time plus the string here, and I need to hold on. I'm supposed to close. Oh, over here. Yep. Okay. I didn't see that. Okay, so now it's looking good. Okay, the only thing is we need to format these values a little bit. So this is the time in seconds. So I can even go ahead and display seconds next to it. So current time, I can say seconds, and then the falling distance, I can concatenate it with the text meters if I want, or I can just put the meters here and then the seconds here on the header. But I want to go ahead and also format this value here. This value that's returned. So what I'm going to do is I'm going to change this from a system.out.print ln function. I can do that, or I can just do a string.formats directly here. Okay. So since I've already created this, I'm going to go ahead and do a string.format just on this value here. Okay, that will also work, but I can change this to a system.out.printf, so just to format the whole thing. So it's easier, since it's just this I'm trying to format, I'm just going to change apply the string.format method on that. So I'm going to call string.format in this method, in this print ln method, and I want to format it. Let's see. Well, I need to. I'll end up breaking it on a new line, anyways. So I want to format it to as a. Well, I know that it's a double, right? So I'm going to say percentage. Oops, it has to go in quotes. So percentage f is going to be the format specifier. I know it's going to be a float, right? So I'm changing it to percentage f. I'm formatting it as a float. And I want it formatted to 2 decimal places, so I'll put 0.2 right in the middle of it. Now 0.2 is the precision of the. It is the precision that, basically how many decimal places I want to format this to. So I want to format this to 2 decimal places as a float. Okay, so the precision goes in between the percentage and then the f, and that's it. So this is the format specifier. I'm specifying how I want the value formatted, and it's a placeholder at the same time. So this results, or basically the value that's returned from this whole method call, is going to replace this format specify and formatted based on how I specified it here. Now this is going off the screen, so I'm going to break it on a new line, and let's compile this and then run it and see what happens. So now you can see that it's rounded to 2 decimal places. We need to push this here a little bit, so I'll delete one tab from here, see if it helps. Okay, so now it helps. All right, so at 1 second it's 4.90 meters, 2 seconds is 9.60, so it's kind of exponential. You can see how it's grown fast. It's going very fast. So this is working. Okay. If you have any questions, please comment down below, and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves, and I'll see you next time with the next program. All right, bye-bye.